Alright, I'll go ahead and get started. Alright, everyone. We got number of the day today and then the link. So make sure you fill out the attendance form for today. Wait, why is this being weird? Being silly. Good? Yeah.
The entire screen being shown.
Just the what?
The entire screen being shown.
I think so, yeah. Alright, everyone good on the attendance form? Need a minute? Alright. You said the link don't work? Oh, what? You said a tiny URL? Yeah.
Yeah, well, we can do that next time.
We'll get that going next time. Alright, otherwise, everyone good? Alright. So if you didn't get the attendance form, just come to us after lecture, we'll help you out. So today we're going to be talking about ListViews and RecyclerViews. Before we get into the lecture, we have some announcements. So the hack challenge is going to kick off November 8th. So this is not too far from now, so just a heads up. This is going to be the 4th lecture out of 6. So after this lecture, there are only 2 more lectures, not counting guest lectures, which are extra credit, but don't have an assignment associated with it. So the upcoming topics for the next 2 lectures are going to be fragments and networking and persistent data storage. So we've talked a little bit about fragments and in the context of activities and stuff like that. And networking is basically just utilizing the internet in our apps. So we can reactively get information that way. Persistent data storage is basically how we'll be able to store things over long periods of time. So after you close something. And we've talked a little bit about that when we talked about the Android lifecycle. So we're actually, for real, doing the mid-semester feedback form this time. So please fill it out. It's 3 points. I think it's 3 points on your total grade. So yeah, but this is, important because, this is how we know how lectures are going and everything, and it's important that we know it. But yeah, we're past the midway point, so yeah. I believe so.
Yeah, you just made it yesterday.
Yeah.
I think so.
Right, so guest lectures, the topics are currently TBD. In the past, we've done stuff like intro to Android game development, Firebase analytics for Android applications, and they're going to be 1 point on your final grade for each lecture that you come to, because we really want you to come. You don't have to take notes or think this is something you're going to use for an assignment, although if you use it on your hack challenge, like Firebase analytics, that's a huge plus. These are really great skills to learn. Just to let you guys know, for homework 4 this week, there's going to be a lot of extra credit opportunities. So, and some of them are difficult, and some of them are less difficult. So, if you want to get extra points, this is definitely a good week to do that. And the drop deadline is the 21st of October, And we're going to be grading homework 1 to 3 before then. So we'll release the grades tomorrow night, fingers crossed. I believe homework 1 grades have already been dropped, but this is sort of just to, for the sake of transparency, so that you know how you're doing in the class. Like I said, we don't really fail anybody, but if we tell you that we think you should drop, then we'll let you know, but you all do very well, so you have no worries. If you have any worries, come talk to us, and we'll work it out. All right, so just a little bit of review from the lecture from last week. So the Android lifecycle is basically like the life of an app, right? This is what we do when we create an app, when we resume an app, when we put it in the background, when we actually close the app. And being able to specify these methods within an activity is how we can specify the actual behavior of our application when these events take place. So understanding this concept from a high level, so that way if you are creating an app where it would be useful to do such a thing, you have the tools to be able to look at the documentation, figure out how to implement these methods. What we typically do is, right, we implement the onCreate. That's what we're always doing when we're making our apps. So we also talked about implicit and explicit intent, and homework 3 should have given you some experience doing intent. So implicit intent is when we're sending data between apps, like if I'm going to share something. Explicit intent is sending within an app, like an activity to another activity, right? The RGB to our HSV activity. The manifest, you can sort of think of this as like the blueprint for your application. This is where activities are declared, where you have to explicitly declare the dangerous permissions that are not automatically granted. And with permissions, of course, you want to code it in such a way so that you prepare for the worst, right? So if they deny your permission, have the fail safety there. Get ready for them to say no to location permissions, and so your app doesn't just totally break when that happens. Any questions on Lecture 3 review? Anything to talk about? Any questions on homework 3 that's not individual? Anything? Cool. All right, so today we're going to be talking about ListViews and RecyclerViews. So before we talk about exactly what all of them are, or exactly like the definition of a ListView and a RecyclerView, we're going to motivate it a little bit with some observations about apps. So here is 3 screenshots of apps. So on the left, we have Facebook. On the middle, we have Podbean. And on the right, we have Venmo. So these are all the Android apps for these 3 companies. And we notice something, right? It's almost like I could, especially for Facebook, it's almost like I have some infinite scrolling interface, right? I could just keep scrolling and keep scrolling and keep scrolling, but it seems the list is not finite, it's infinite, right? And I just, but we know that there are some limitations to that, right? If I scroll super, super fast, eventually I'll see like, it starts to hiccup as it's like loading in new posts and new posts. So this sort of shows us that behind the scenes, all of these posts, right, each individual cell here is driven by data. There is data that underlies every one of these. So there's some data for this podcast, for example, the New York Times, right? So this has the author, the most recent whatever, and it's also under some category, which itself is a piece of data. So it's this idea that all modern apps are really data-driven. And what we've been doing so far has not been using a lot of data or structures that can let us use data. So here is now 2 examples to understand what a ListView and what a RecyclerView is. So from a very high level, I'm just going to say that a list view is sort of like a quick and dirty way to make lists in an app, in the Android app specifically. It's sort of like if I have some finite set of data. It's not very complex. I don't need a lot of calculations for each piece of data. I just want to display the data. So for something like that, I would use a list view. For something where maybe I'm loading in complex assets, the interface is a little bit more complicated, I'm doing calculations, I'm waiting on network requests, things like this, it'd be a lot more likely and a lot smarter to use RecyclerView because it's more efficient and it's better built and at this point industry standard. So here we have this breakfast station menu from the Eatery app. It's like a very simple, just text cells. Whereas here we have a card view from the Eatery app also, where we have images and it has badges and more complex data, I suppose, although still not very complex. So this would be an example of a recycler view and an example of a list view. So now to get more in depth about recycler views, we're not going to go too much into list views. If you'd like to learn it on your own, it is on the course textbook. We talked a little bit about it, but like we said, we kind of want to discourage it. We want to encourage what industry standard is, and industry standard is recycler views. So you can think of a recycler view as a way to represent a list in an app. This is how I can move data and put that data directly into my application. So you can sort of think about it as one piece of data, although this piece of data could be comprised of many pieces of data, right? What we saw before was one card view actually had an image, a name, like the time it's open, all of these badges about the meal types that they accept. So piece of data is sort of some segment. And so you can think of each cell as one piece of data. So this is how the recycler view can represent the data in the app. So only the cells that are immediately visible to the user are created at runtime. This is how it's able to be so efficient. So remember how we were talking about Facebook being this almost infinite long interface. And if I scroll super, super fast, then eventually you start seeing that like only the shape of the thing is there. You're not actually seeing the data anymore, and it's like loading in the data. So this is sort of playing on this idea that it hasn't rendered it yet. It has to take time to render it because it doesn't anticipate you scrolling that quickly, because most people don't scroll that quickly when they're actually reading a Facebook feed. So the hidden cells are rendered as you scroll. So there's usually a buffer though. So if maybe like 10 posts below where you're at currently, that's when they'll start rendering it. Because if they immediately render the one under the one you're looking, then maybe you just skip past a post and it's still rendering, and that wouldn't be very user-friendly. So it's this idea where they're sort of doing it behind the scenes in an intelligent way so that you don't notice it as the end user. And so the recycler view also utilizes the view holder pattern to avoid the amount of times it calls view.find view by ID. So there's a very specific reason why it doesn't want to call this. This is actually a very costly method call in Android development. And so they want to minimize this as much as possible. And for anyone who knows anything about complexity and computational complexity, and you compare what would be maybe a 1,000 item recycler view with a 1,000 item list view, if the list view calls on find view by ID every time, whereas the recycler view only does it when it needs to, then you'll have huge savings, absolutely huge savings. And I'm sure everybody knows like the amount of background processes phones have. It can be a very slippery slope to have a very unperformant app. And so this is a very important thing. And it's also why it's called sort of a recycler view, because it's recycling these sort of views over and over, rather than constantly creating new ones and calling them. So as the user scrolls, the recycler view will either create new view holders or reuse the view holders that have been off-screen belongs. This is how it is able to be so efficient. So any questions on recycler views from the conceptual level? Yeah. So we'll talk a little bit more about the view holder class and the implementation and stuff, and more about what it is. But I think it's on the next slide. So. Any other questions? Okay. Okay. So how is a recycler view? So how do we do recycler views? So you need 6 things. And we sort of mentioned them from a high level. So of course you're going to need the data, right? You're going to need the data you actually want to display. This is what you populate your Facebook feed with. Whatever the post is, whatever comprises a post, right? You're going to need the recycler view object itself, which contains the item in the data set. Then you're going to need a layout for a single cell. So this is important. Anytime I'm creating a recycler view, I need to specify what the layout looks like for the cell. So usually when we've created layout files, right, these XML files, they've specified what the whole activity looks like. They've specified we have a button in the top left and then something over here, and like the color square and then the 3 sliders, right? So this is us creating an XML file specifically for one cell. So in the example of the eatery app that we saw, each card would be that instance of that layout. So like an image and then some title and then some more text and like the little badges. So that would be the layout file that we create for a single cell. So remember before we said one cell equals one piece of data. So that one cell is what we're talking about here. We're going to need a layout manager. We'll see more about how the layout manager works in demo and the implementation, but the layout manager is the common one a lot of people use is the linear layout manager. It organizes the layout of the UI, it helps us do some things in the class file to the actual XML layout. Then we're going to want the adapter. So this is one of the more important parts of the recycler view. The adapter is what allows us to actually connect the data to the recycler view. So this is doing a lot of the conceptual things with the data. It rebinds cells on the data change, so every time something has changed in the data set, it will rebind the cells. And once again, this is another thing that will make more sense once you get your hand on the keyboard or looking at the actual implementation. So the view holder is a class that holds information about how to display an item. So basically, it's going to be important because this has a lot of different information when we're actually using it in the recycler view, and you'll have to create instances of this class when you're actually implementing it. Just so you know, there is boilerplate code on how recycler views work, and we encourage you to use it, especially in the early stages of Android development, because this could be one of the more confusing topics. So, you know, don't be a hero and try to like memorize and recite this code from like the top of your head. Use the resources that we give you so that you're not lost trying to figure out everything. Focus on the concepts now, and then the more and more times you do it, the code will be more natural. Okay, so why recycler view? Basically, the answer we've said so far is performance, and the untold answer that only I'm saying and is not on the slides is that it's industry standard. This is what companies use. So if you want to actually do Android development at a company, like an internship or something, they will likely be using a recycler. This is sort of a visualization of how we can see that items are sort of being recycled. So the each item here is being recycled as you go through and iterate through the list. And so imagine it like every maybe 30th post on Facebook, you're seeing the same view that you saw on the very first Facebook post. So this is sort of the idea. Okay? So we're going to look very briefly at ListViews. Don't worry too much about it unless you sort of want it for your own projects, or like maybe you find a need for it in the hack challenge. But just know that for the homework, you don't need to do this. I don't think we'll ever ask you to do a ListView. But here is some of the code of just an example. We're not going to spend too much time on it, but it's bad practice for the industry. You can use this for unchanging lists, usually made of text. It doesn't reuse memory well. It calls on find view by ID a lot more than it should. But it's simple, easy to implement, the quick and dirty way to make a list-based app. Okay. Any questions about the contextual part of lecture today? All right, very good. On to the demo we go. Oh, and after we finish demo today, we're going to do a little detour into talking about homework 4 more in detail, or we're going to show like examples and give like hints and stuff.
I'm gonna figure out like where to put this thing. Okay. All right. Yeah. So we're gonna start off. Basically, we're gonna make an app that's pretty similar to the homework. So what this app is gonna have first, we're gonna have like a main activity, and in that main activity, we are going to have a recycler view. And so if we look at the resource layout file corresponding to this main activity, after it finishes initializing, you will see that we have, as usual, a constraint layout. And this time we have a new type of view. We have a recycler view in here. And you can just like create one as you do like normal views, such as text views. Just do like, like let's say recycler view, and you can click on that, and it'll just autocomplete, same as other views. And you can add constraints. One neat thing about height is that if you set something's height to 0 dp, the height of the view will just match its constraints. So if you ever want to do that in your app, you can just set the height to 0 dp, constrain its top and bottom, and then you can sort of like have it expand to match its constraints. That's just a little tidbit that you might find useful. And so what's going to happen is we're going to have a list of like, say, to-do items in this main activity, right? And we're going to be able to click on each cell of the to-do list and be taken to a second activity. Just like you guys did with like HSV activity, you guys can sort of navigate to a second activity by clicking a button. This is going to be similar, only we're going to be able to navigate to another activity by clicking on each cell in the recycler view. And we're going to be able to do stuff in that second activity as well. But first, let's start doing some coding for the main activity, because right now we have the XML for the recycler view, but we haven't actually done anything to that recycler view and on create, so it doesn't have any data right now. So any questions so far about like what our plans to do? Our plans are to basically populate this recycler view with data using code. Any questions on anything we've seen so far? Nope. Okay, sounds good. Okay. So as Adam said before during lecture, we want each cell of the recycler view to be holding a quote-unquote piece of data. And in order to represent that piece of data, we're going to use a class. And we're going to use something called a data class. And that's so called because like data classes are a special feature of Kotlin, specifically used to represent basically pieces of data. They're usually completely immutable, like you can't like change them afterwards because you don't like want your data not being what it was originally. So that's how we're going to represent each piece of data in our to-do list. So let's get started first with that. I'm going to create a new class, and it's going to be a data class, and I'm going to call it to-do. So this class is going to be a data class that represents each to-do item in my list. And I'm going to give up a task and give it a color. So each to-do is going to have a task and it's going to have a color because I like having color-coded things. And it's going to be an int. The reason it's an int is because I'm going to give it basically a color resource ID. And those resource IDs have type int. Any questions on data classes? All right, cool. Let's continue. All right, so in here, I've already populated some things for the to-do. So what we're going to do is we're going to create a sort of list to hold the to-dos. And this is going to be sort of like similar to a regular like array list in Java, not like really the recycler view yet. So I'm just going to call it a private val, let's see, to-do list. And it's going to be a and this is going to be a mutable list because in Kotlin, lists are by default immutable. So this is a special constructor you need to do when you want to create lists that have to be mutated. And now here in the actual onCreate itself, I can sort of populate this to-do list. I can say, I'm going to do a for loop, and I'm going to say for I and task indices. And this is kind of like a for each loop. Task.indices sort of like lists out all the indices of tasks, so it's going to be like 0, 1. So I is going to take on the values of like 0 and 1. It's sort of like a for each loop in Java. And any questions so far? No? Good. Okay, so I'm going to add to this to-do list a new to-do containing the current to-do I want to add. All right, so after this block of code, basically all the tasks and colors, I converted them into like to-do data classes, and I've added them to my to-do list. Any other questions before we move on to making the adapter that's going to actually populate this data into the recycler view? Yes, no, maybe so? Okay, no. I'll take that, and let's create the actual adapter that's going to take this data and put it into the recycler view. All right, we are going to create a new Kotlin class. I got to give it a name, like to-do adapter. Very nice name. Okay, so to-do adapter, in order to allow it to put the data into the view, we actually need to basically give the data to it in the constructor. And in Kotlin, like constructors, in Java, you would sort of like write the constructor inside the class. In Kotlin, the primary constructor, like the main constructor, you actually define it like immediately right next to the class. So I can say, okay, the constructor is going to take a list of to-dos. and that will basically make the to-do adapter's main constructor take in the to-do list. And the second step of creating this adapter is that we have to sort of create a view holder class. And like what I'm going to type right now is like a lot of syntax stuff. So this is like kind of stuff you don't have to like memorize. I will like point out the parts that you do need to know, because there are some parts that you do need to modify for your like actual implementation. So I'm going to create a view folder. And I'm going to like explain what this does in a bit after I finish typing. Let's see. Okay, imports. Okay, I guess this isn't really needed. All right, so what this constructor is I'm saying, okay, we're defining this class view holder. It's going to have, this constructor that's going to take in a view. And what this is basically saying, okay, this view holder class is going to extend RecyclerView.viewHolder, which is another class. So this is the superclass of this class. And this call right here is the equivalent of saying like super item view.
If I may, I realize the next slide didn't explain it as much. So to answer your question, like more completely, so what a view holder basically is you can sort of think about it as like something that holds some view, like a text view or something, and it just has like information about like the metadata of like what it is, like where it was in the list and stuff like that, like its index.
Okay. Internal, nothing. Okay. Anyways, so what we want to do for this view holder is we basically want to like do find view everything, like all the find view by IDs inside this view holder class constructor. And you know how like normally in your like on create you say, okay, I'm gonna find view by ID yada, and I'm gonna like assign it to a variable, right? That's basically all you're gonna do in this view folder. So for example, I can say val checkbox equals and I am going to, after this, show you. Realize there's one more thing I forgot to show, and I will do that after. Okay, so this is like finding find view. This is calling find view by ID, and this is sort of working with the XML of an individual cell, which I'm going to show you right now because I realized that I forgot to show you earlier. So as Adam mentioned during lecture, for each cell of the recycler view, you're going to like want to create a layout that sort of like is the template for each of those cells. So in your layout, I have created like a to-do cell here that represents like the XML for a single like list item basically. And this is just like a normal layout. You can see we have a constraint layout, and in this constraint layout, I have like sort of like a colored square and like a checkbox just to like represent the color-coded thing of my to-do list item, and also a checkbox to like actually hold the to-do list item itself. So this is how you define XML to sort of represent each item of your to-do list. And you can, yeah, create it in layout just by right-clicking on layout. If I can know how to right-click on this computer. Clicking on new and saying layout and creating a new layout resource file. Any questions up to this point? Okay then, back to the adapter. We've already done the constructor for the view holder, and now we are going to actually do the rest of the logic. And to do that, we are going to do something else here. We're going to say this constructor. We're also going to make this entire class have a subclass relationship with another class. So basically, we're going to make this class extend another superclass. And because we want that superclass to do a lot of the heavy lifting for us, while we focus on the specifics of whatever we do in our list. So this is, again, syntax stuff. Chapter. One thing to note though is that you do want to in here in these angle brackets, you want to give it your adapter name dot view holder. So it's it's parameterized on basically this class right here. So you have to put this in here. And right now it's complaining because it's okay, we have some methods that aren't implemented. So I'm going to hover over the complaint. I'm going to click on implement members. I'm going to click on all three of them and say, okay, I want to implement them. And IntelliJ/Android Studio will auto-populate these to-dos for me. Here comes some more syntax stuff, things that you don't have to memorize, but things that you will probably have to type. So in onCreateViewHolder, we want to actually sort of call this viewholder constructor, and to do that, we have to first create the view itself. So we're going to say we want to create a view. And I will sort of explain high level what this is doing in a bit. So, to do so. Okay, so what this line of code is doing, it's basically saying, okay, we have an XML and we have, this parent view group that we want to and basically we want to sort of use this XML to create a view, and afterwards we want to say, okay, its parent is this parent right here. And after we've created the view, we can pass it into the view holder, so that way all these find view by IDs gets called. Any questions on this method? All right, now this is a lot of syntax stuff again, so it's not really stuff you need to memorize. Okay, so I'm going to do get item count next because bind view holder is a bit more complex. So get item count is just returning the total number of items in your list. And this is just going to be to-dos.size for us because that is the number of items in our to-do list. And finally, bind view holder is the very last thing. This is basically what does the heavy lifting. This method is what actually takes the data in our to-dos variable right here and actually puts it into the view. So what we're going to do here is going to say, okay, which to-do object are we going to look at? We're going to look at the to-do object in the position because this position parameter is basically telling us, okay, which list item are we looking at? So we want to grab the data corresponding to that item position. And after that, okay, we want to say we're going to grab a folder. And now that I click on dot, you can see that the things we bound up here, the checkbox and the color view, they're both available down here. So now we can actually access these variables, and you can like treat them just as you would like if you did find view by ID, just like these are like variables and referring to like a checkbox, for instance, and then you can actually do things with them. So I can say, for example, this checkbox set its text to to-do.task. So just like treating it like an ordinary variable. And similarly for the color view, I can say, okay, set this color view's background resource to the resource that we have in our data. And finally, we can actually add an on-click listener to the entire view holder itself. So that's how we're going to do things when we click on a list item in the recycler view. So I can say holder.itemView .set on-click listener. And I can do stuff in here after I click on the cell. This is kind of a lot. Any questions so far up to this point? All right. In that case, we're going to move on. And basically what we want to do each time we click on one of these items is we want to start another activity. And in that other activity, we want to basically like populate that other activity with all the details that we have in this item right here. So we're going to give that other activity the like color code of the current to-do, and we're going to give it the name of the current to-do. So to do that, we're going to use intent, same as you did in your last homework. And before we do that, in order to create intent, we usually need to use a context in the constructor. Right now, we actually, because we're not in an activity, we need to get the context from somewhere else. So I'm going to say val context equals folder.itemView.context. This is, again, another syntax thing. Just remember to get the context from like the holder's item view. Okay. I'm going to create a new intent. Same as you did. So this should be review. Alt enter. Going to give it the context. Going to go to do activity class.java. And then I'm going to say, I'm going to introduce you to some extra syntax. So what you guys did earlier when you like transferred, like when you like added extras to intents, you probably did like, you know, you created the intent and then you did intent.put extra, intent.put extra, intent.put extra, right? And that repetition of intents can be really annoying. And because programmers are lazy, we created this extra method called apply that does everything to the intent without actually having to write the name of the variable again. So instead of doing to do intent.put extra, I can directly in here just state like put extra, and you know, let's say like the position of this. So now I have saved myself some typing by not having to type in the name of to do intent many times. And start activity. To do intent. And again, with here, usually, like if you're just like in an activity and you call like start activity, you don't like need the context. But in this case, we need to like actually add the context here and tell it to call start activity. Because you're no longer inside an activity, and activities by themselves are basically our context, so you don't normally need this. But in here, in the adapter, you do need this extra variable right here. Okay, and I think that concludes the creation of the to-do adapter class. Any other questions before we actually, in the main activity, go hook up this adapter and use it? No questions. I can't really tell if that's a good or bad thing, but moving on. Okay, so we have created our to-do list, and so now we're going to create our adapter. And we're going to create an instance of our to-do adapter and pass it our to-do list, which is our data. And voila, we have successfully created our adapter. But not all is done yet, because we also have to actually tell the RecyclerView what its adapter is. And we can do this by saying RecyclerView.adapter equals adapter. Finally, what we have to do after that is we have to give this RecyclerView a layout manager, which Adam mentioned in lecture. So for this type of RecyclerView, we're just going to use a linear layout manager, so it displays things like linearly. And we can say RecyclerView.layoutManager equals a linear layout manager, and we're going to give it a context of this. We're going to say we are going to display things vertically in a vertical list. And there's going to be like some other stuff. We don't want to reverse the layout, so we want to say false for this. And that makes sure that like items are displayed vertically in a linear way. And finally, what we want to do after navigating to the to-do activity is, I'm going to actually show you what the to-do activity is doing. So when we click on each cell in the original RecyclerView, we are taken to this to-do activity. And in this to-do activity, we are basically allowed to edit the name of the task. And we are going to pass that edited name like back to the original activity. This is similar to what you guys did with intent and homework 3 as well. And in order to basically tell this adapter that we actually got some updated data, we're going to actually have to modify the information in to-do list. And so we are going to say, okay, suppose we got some information from the intent, which means, which means the user edited the name of the task and stuff and like sent the information back to the main activity. Then we can say, okay, take the to-do list, and at the position of position, we're going to modify that to-do and just replace it with this new to-do, which is basically the modified information. And after this, we need to like tell the adapter that the data has changed, because for the sake of efficiency, like the adapter doesn't automatically like re-update things unless it knows that the data has changed. So we have to say, okay, adapter, we are going to tell you that an item has changed at position. And what are we doing on time? We have 1 minute left. Okay, if Gradle builds within this 1 minute, and my app does not crash, you can actually see it working. I'm going to preface this with an if, because I know my computer does not Gradle build within 1 minute. Question? Do we usually have a policy of doing that?
I think the boilerplate code is pretty similar on the textbook. If you still really want this, maybe we could send it out. You said what?
Huh, interesting. In that case, you could like look at our YouTube video, screenshot it, and convert it to text, I guess. I don't know. Okay, this might not actually finish building. Okay, time is up. This is my finished building. Yeah, any questions while this thing builds? Technically, lecture is over, but yeah, any remaining questions?
And now the question is to do adapter.
And to do adapter?
Yes.
Okay.
Like in the onClickView holder method, what does the parent age here?
Oh, this is parent view group. It's just like I think view group is like the actual like RecyclerView itself. If I'm not mistaken, it's like the RecyclerView. It's like it's the parent of like all its children, which are the items. So it's just like, yeah.
So the view holder itself is within a view, right? And so the view is represented as a view holder because it could be within some other layout sort of thing. So it's just, the parent is sort of, just think of it as the larger layout structure. Alright, so it built.
It built, okay. Maybe I can actually click on this thing. Okay. I'm going to make dinner with a capital D because I'm hungry. And yay, it got capitalized. Thank you very applause. So yeah, any final questions? Otherwise, we're probably gonna like wrap up lecture for the day. Other announcements?
Yeah, after we finish everything today, like I said, we're going to project like examples of the app and like some pointers and stuff. But were there any other questions on the demo? Cool.
All right, sounds good. Thanks for showing up to lecture, and yeah, come talk to us if you didn't have time to fill out the attendance.